hope nobody's burned out on security. I know we just hit that hard. We talked a lot about security. So today what I want to do is tell the security story in a slightly different way. I want to talk about a security development lifecycle. And today I hope to convince you that there's no set of tools you can buy that's going to make you secure. Security is a human problem. And we're going to talk about some of the ways that you can integrate that into your development process to be more successful going forward. So my name's Justin Hutchings. I'm a product manager at GitHub. I've worked on a lot of the features that you saw Jamie and crew demo earlier. And my background has been a software product manager for a long time. I've worked in organizations of varying levels of security consciousness. And one of the things I've seen is that security is often an afterthought. Even great organizations often have to be reminded that security is the existential threat for every one of our products. It doesn't matter how good your features are. It doesn't matter how clean your UI is if no one trusts you. And so I thought sort of long and hard about what message I wanted you to take away here. And so I threw the word soup here on the screen to try and figure out which one of these catchphrases we should go for. You've probably seen these in the marketing material from half a dozen companies out on the show floor, right? Shift left or defense in depth. I sort of created one that was new here. There it is. You can't wave a magic wand and be secure. That's just not something you can do. You need security to become a comprehensive part of your software development lifecycle. And so today I'm going to tell you about 3 different things. I'm going to tell you about some past security incidents. I'm going to try and demonstrate to you that it didn't matter how sophisticated their tooling was. I want to demonstrate to you that security incidents can happen to any one of you in the room. We'll talk about what the security development lifecycle is, and then recommend some specific practices that everyone can take back and implement in your organization to protect you from the common kinds of security issues that you might encounter. So I'm going to talk about 3 security incidents today. I've redacted the names. And I've done so because any of these incidents could have happened to anyone in the room. There's nothing special about these incidents or about these companies that any one of us would have been vulnerable or immune to. And so let's go through those. First, I want to talk briefly. Hang on. Maybe. There it goes. First, I'll talk about an issue that happened with a financial company. And this is a really interesting one because there was a hostile actor, and they went fishing for credentials. So they're sending emails into the organization and seeing if they can get anyone to bite. And they got one person to bite. They provided their password and their username, and they installed some malware. Now, this problem was compounded because once they had access to that user's credentials, that user had a VPN that got onto the production network. And so with those credentials they had and the vulnerability, you can see they went searching through the network to see if they could find anyone that they could get into. They found one server that didn't require 2-factor authentication. And with that, they were able to get access to the production database. And these are the sorts of things that can happen to anyone. It was a configuration issue. One user made a mistake, and then one developer made a configuration issue. And so the origin here was a phishing attack. Some malware on a PC. Pedestrian stuff. The escalation, we had a VPN with production access. It didn't do health checks. It didn't find the malware. 2-factor authentication was missed on one minor server. And then, they didn't have the data security to isolate that database from those lower security services. ultimately what ended up happening is more than 70 million accounts were breached, and it cost the company $10 billion for a phishing attack. Let's do another one. It's not special. We'll talk about mitigation. So in this one, there are a number of things we could have done. Obviously, more user training helps prevent phishing. Not everyone is an engineer. Not everyone has sort of the security spidey sense. And so having that phishing training is really important. And then if you get phished, do you have a reporting process in your organization so that people can let your incident response team know that someone tried to phish you, so that someone that might not be as security conscious maybe could be protected because they found out about an attempted phishing attack? Obviously, anti-malware scanning, especially on machines that have access to prod. That could have helped. If they'd threat modeled all of their servers, they might have found that they had the one that was missing 2FA. And of course, monitoring. Once the user was in the system, there were all these errant network calls trying to find a server that would work without 2FA. They had all these login attempts that failed because I'm going to assume the user didn't click the approve button on the 2FA prompt. Those should have triggered on so many of things, and they didn't. Let's look at another company. We'll call this one Credit Company. This is going to maybe seem a little familiar for you. You've got a huge server farm. You've got tons of microservices, tons of instances. And we're all using open source in our supply chain. You may remember back, there was a particular open source vulnerability that allowed pretty easy remote code execution from a network endpoint. This company knew they had a great monitoring system in place. Their security team let everyone know there's this problem. They told everybody, go patch. This is a big vulnerability. They sent the emails to everyone. The owner of one of the servers didn't see the email. He didn't patch the server. And no one followed up. And so an outside user went poking around to see if they could find any networks or any endpoints in the network that had that vulnerability. It had a very identifiable network pattern, and so they found it. Now they're in. They've got a foot in the door. And from there, what they found was that the monitoring systems were offline. So they had a remote code execution system, and this company had a great security system they'd purchased. But all of the SSL certs for that security system were expired. So all the traffic that happened in the data center was encrypted. They couldn't tell what it was doing. And so they were effectively blind in the organization. This one gets better, though, because there's another common mistake. One of the servers had plain text credentials on it. And eventually that user, from scanning the network, found those credentials, brought them back, and then used those to access the database. Once they got into the database, they managed to get, they scanned 48 different databases. They found a whole bunch of valuable data. Ultimately, they were in the network for 78 days without being detected. So what was the origin here? One unpatched server. And then no one was caught because the network monitoring wasn't working. And then they had that plain text credential cache that was leveraged for an EOP. This cost them 100 million accounts and more than 5 billion in financial damage. And I think all of you are probably thinking, there are so many servers I have. Do I know if they're all patched? Do I know that no one checked in a honeypot full of credentials? So what are the mitigations here? Well, obviously, better monitoring. Jamie talked earlier today about how we're offering some tools for open source dependency management. You should be using something for this. You've also got to make sure that you have a process in place to deal with everyday things like expiring certificates, maintaining your servers, doing service health. Obviously, threat modeling. If they had gone and found that they didn't have a credential store, there was a plain text place that everyone was pulling their creds from, that would have been identified during a threat model. And then pen testers would have had a heyday with all of this. Finally, I want to talk about one, and this one's a favorite of mine, because it actually used part of a platform I worked on. story time here is I used to work on print drivers, of all things. Sexiest technology in the world. Everybody use print drivers? Yeah. So one of the things that's really interesting about Windows is print servers are a software distribution endpoint. IT administrators hate this, because why would you distribute software from a print server? But it's something that happens. And so the Stuxnet worm was a really interesting one. This happened ages ago, and I'm not going to redact this one because it's super fun. But this was a case where we had a couple of as yet unknown state-sponsored actors, and they had a target system that they wanted to breach. In this case, you can see our fun little nuclear icon there. They wanted to get to a collection of industrial machines made by Siemens. And those machines were centrifuges that are being used for nuclear enrichment in Iran. And so they knew their adversary was air-gapped. And so they had engineered a system to automatically replicate on a network and propagate by any USB key. So let's see what that looks like. So you can see the vulnerability, once introduced, propagates on the network. And then if there are any attached USB devices, it'll jump onto that and infect those machines as well, and infect those networks. Once it's on a network that has one of those Siemens centrifuges, it tells it to spin out of control, and eventually they explode. Now, I'm giving you this example just as way of contrast. The first two vulnerability incidents we talked about, super pedestrian. This one wasn't. We ended up with. There it is. We ended up with 4 unique 0 days on Windows, as well as a compromised trusted cert that allowed the software to propagate without any install prompts. It expanded itself by infecting devices via the network, as well as using USB devices to jump an air gap. It infected about 200,000 computers and destroyed 20% of the Iranian nuclear program. And so that was a very specific attack from a very motivated attacker with extreme capabilities. And you think about the mitigation here, I guess they could have stuffed their workstation's ports with epoxy. This isn't what you're defending against. The majority of attackers that want to do financial damage, that want to get information that they can sell on the black market, on the dark web, as it were, they're not going to design things to jump air gaps. And the amount of effort that you're going to spend to build an air gap network and build out this culture where there's such a stuffy sense of security, you're going to kill all of your innovation. That's not your risk factor. The other things are, the low-hanging fruit. And so what did we see across all of these? Obviously, there's human error here. Human error is the #1 source of security vulnerabilities. We also see limited threat modeling, and this is really a social process for how we engineer software with security in mind. Of course, insecure development practices and ineffective validation made it worse. If we had the right pen testers, if we're using great static analysis tooling, any one of these vulnerabilities might have been detected. And then finally, you think about this whole assume breach. If you don't have monitoring, you can assume they're in your network all day long. You're never going to know. And so I hope at this point I've convinced you your security threats aren't state-sponsored actors that are going to jump air gaps and go attack you to blow up all your equipment. They're financially motivated hackers that are going to find the low-hanging fruit because there's a lot of it. And so what I want to do is shift to the positive part of the talk and talk about why you should add a security development lifecycle to your software development lifecycle. And I'm going to mirror sort of the pattern that I showed in terms of the common problems with the solutions to those problems. So you start with training. Humans are a weak link. They operate unpredictably, And if they're not educated, they will do bad things. Not intentionally, obviously. You also have to make sure that you integrate security design into your software, as well as secure development practices. We'll also talk about verification techniques that you can use, and then finally monitoring and response. Because security incidents will happen. Every one of us in this room will be part of an incident response at some point in our lives. And so having the process to respond to it makes your life a lot easier going forward. All right, so training, this is the boring one, right? Everyone goes, ugh, like training, sure. And you know, I want to start like, yes, you need to do things like account security training. You got to tell people you're being phished, you need to use 2FA, you want to make sure that you're communicating securely on security issues. But you know, let's go to even a more basic thing. Does your team know what your security policy is? Do they know how to disclose a vulnerability to your customers? Do they know, you know, whether or not a service is maintained or supported? Do they know what kind of data they can put on servers? Do you have encryption policies that they should be respecting? Do you have threat modeling that you've trained people on? We'll talk more about that in a bit. Does everyone know how to use the verification tools you've purchased? Everyone in this room has probably spent inordinate amounts of money on software that will protect your systems. But if your developers don't use it and don't know how, it's not going to get you a lot. And then finally, when there is an incident, do people know how to respond? Do they know who to go to? At GitHub, we have a great thing. We have the oh shit alias when you screw up. And having something like that, we all laughed like when we're at the orientation and they say, yeah, email oh shit, we're not kidding. That's what it's called. You'll never forget it because of that. And you make it something where every GitHubber knows this. That's what you do. And so when there's a phishing attack and you respond to it, you did the wrong thing because it was really well done, that's what you do. And we protect each other. If I haven't convinced you on why humans are your biggest risk, I want to point to this great tweet here from Joe. So there's an app on the Google Play Store. I don't know why they published it. This makes no sense to me. It's an app that automatically accepts Duo 2FA pushes. Because some people go, look, security team, you made this too hard for me. I just can't be bothered to get my phone out of my pocket, so this accepts it. More than 1,000 people have installed this thing. The negative reviews are all from security people that go, oh my, don't, please. This is a terrible idea. I know it's painful, but please don't do this. But your users are your biggest risk. So let's talk about, design phase, architecture review. How many of you have an architecture review board? Anyone in the room? A few, okay. How many of you do threat modeling? Do the little data flow diagrams and what have you? Very few, okay. So, I had a developer I worked with ages ago, and I was some young out of college guy going through our security practices, and I'm like, we got to do threat modeling. He's like, we're not going to do that. No, we have to do threat modeling. It's really good. I'll show you. So I built this big data flow diagram to describe these legacy systems that had been in place for 15 years, and we found real vulnerabilities. At the end of it, he said, I'm glad you made me do that. I said, I'm glad you did it, because this is what we have to do. We have to have the conversation about how these things work. The types of vulnerabilities we were dealing with at the time were things like, do we have insecure data stores? How do we ACL down the data that we execute? Do we have data that we're running or parsing, right? Do you process images? Well, there's an EOP risk right there, because if someone can break out of that image parsing code and overrun a buffer, well, all of a sudden you're now vulnerable. And so you go through and you have to figure out, what are your trust boundaries? Where are you accepting input? Where are you storing things? How are you interacting between your microservices? Microservice-based architecture, by the way, is one of the biggest security boons and risks that I've ever seen. Because people will say, I want to isolate all my things, but then I give them full token access to everything. And so now you have 50 different endpoints that you can talk to. And if you find one that's over-permissioned, well, you lost. And so threat modeling and architecture review are amazing processes, and I hope everyone adopts them as part of your flow. Once you get into development, obviously, you're going to be writing your code. You're going to be doing the normal things you do. But as we've heard all week this week, open source is an increasingly large part of development, right? Do you know what open source you're using? Do you have an inventory? And did the developers that brought it in tell you why they needed it? Because one of the biggest challenges you have is you bring in an open source dependency, maybe you used it for a prototype, you never got rid of it, you aren't using that code path anymore for production, but you still have the vulnerabilities there because you've inherited all those things. One of the things we do at GitHub that I'm really excited about, we do a security review. And so for every feature that goes live, we open an issue. There's an issue template. We fill it out, and they ask us all these questions. They're like, do you accept user data? Do you use these particular architectural constructs? Where do you store things? How do you audit? And we go through this sort of social process with our security people. And it's really important because they're not on the ground every day discussing what you did, but they come through and they say, ooh, that looks risky. Can I see your PRs? And they'll go through and review the PRs and say, ooh, this right here we should probably change. And when they tell you to change it, this may seem obvious or rudimentary. Do it. Like, mitigate those things. Even when you're doing conference-driven development, you've got a deadline. It's better to miss your conference than it is to ship and have someone pwn you the next week, right? Like, all of your great press goes out the window the minute you get exploited. And so take your time and make sure that security has the right to say, no, you can't ship until you fix these things. Verifying, obviously. This one's later, you think about the shift left paradigm, right? We're already after development. We've maybe shipped some things. How many of you use pen testing or employ a red team? Okay, fair number, good. How many of you are using static analysis? More, good. I like that. And then fuzzing, maybe, okay, a couple. So, the key lessons that I think are here, regardless of how good your practices are, it's always good to have something double check you, because things slip through the cracks. It's a big, complicated world. We all know how hard software is to write, and these things help. I'm not going to, belabor the point on static analysis. Fuzzing, let's go into that briefly. So fuzzing is an amazing thing, and it's a lot easier than it used to be. There are a lot of open source tools out there that help. We used to have to take a well-known set of files and bit flip and do all these random things. You don't have to do that anymore. There are tools that will help you with your fuzzing and help you figure out how to protect yourself. And you should use them because they're an amazing way to protect yourself when you're parsing data or accepting input from any users. All right, let's jump ahead. Finally, monitoring and responding. So we talked, all of those incidents we talked about could have been prevented with some monitoring, some really good network monitoring, some great open source dependency monitoring. Obviously, as Jamie told you just last hour, we've got the dependency graph, dependency insights. I hope everyone will use those. They're free. But you also have to recognize what your inventory looks like. If you're a C++ house, we can't do much for you. There are commercial products out there that can help, and you may have to buy one. Or, if you're primarily running, you're primarily running systems where you're vendoring in your software. Do you have a process where you can monitor what you're actually using? Do you know what's vendored in? Do you know what the versions are? Do you know where they came from? I remember when I worked on a previous team, we had 15 copies of one open source library checked into our monorepo. There were different versions. They had been forked because people had said, ooh, that one's really good, but if I change this one method signature, it's better. And then when the vulnerabilities come out, you go, now I have to handwrite everything. I have to go back and look at all these things. And I've moved on to the next thing. And so you've got to have a process to keep these things going, to monitor the risks that are going to be facing you going forward. And then response, of course. Does everyone have an incident response plan? When you find a vulnerability, how you respond to it from an engineering perspective, from an investigation perspective in terms of what the damage actually was, how you disclose those things. If you don't, now's a great time. There's no better time than now. One of the things that GitHub added earlier this year as a capability is the ability to describe a security policy. Jamie showed that earlier. And it's one of those things, you think about the verification and hacker-powered security. Telling people how to contact you when they find something is so important. I've gone to so many open source projects, and there's literally no way to contact them for security things. I've had to post issues and say, I'm aware of a security thing. Will you please contact me at this email address so we don't disclose everything to people? So give them a chance. Go to HackerOne, put up a secure email box, do something. And then when you actually get to fixing things, make sure you do it in a quiet place. It wouldn't be appropriate for everyone in your organization to know you have an unpatched security vulnerability. We talked about the human risk. People talk. Have a policy in place for who gets to hear about these things, who's involved in incident response, who's in the tent, as it were, on these things. And then finally, publish a CVE. This is one of the best ways that we can improve transparency and security across our ecosystem, is to tell people when we've patched a security vulnerability and what has to happen. It's not enough to send a thing to your user forum. It's not enough to tweet it. Put it in the CVEs so people can actually discover it. And then it flows into all the incident response organizations in every other company that consumes your software. So recap. Security incidents can happen to any one of us. Every one of us in the room will deal with a security incident in your career. And you should bake security into every phase of your software development process so that it's cheaper than cleaning up at the end. You don't have that reputational impact. We talked about how you want to train your users, because your users are often your greatest risk. You want to implement design reviews so that you can protect from issues before they've even been authored. You want to have secure development practices. You want to make sure that you have protected branches, and you have code review, and you have security review. You want to have people be empowered to say no when there's a security risk. Verification. Use the ecosystem, use the community, use pen testers, use bug bounties, and use great static analysis tools and great fuzzing tools that can make you more productive. We're in sort of the golden era of software security, but it's also the scariest time because there are more risks than ever. And so it's okay for all of you to go back and be that advocate for how we do better, how we prevent the next one. What I want to do sort of as a parting note here, and we'll be around later. There's a capture the flag exercise over in the Connect space. But I want to give you a couple of resources that I really personally like. A couple of books from Microsoft Press that I'm a big fan of. Do people like writing secure code too? Or is that a fun book for people? It's good bedtime reading. I'm also a big fan of the threat modeling book. If you haven't done threat modeling before, it is such a good practice to bring to your organization. And that book walks through categorizing issues, how to diagnose them, what a repudiation attack even is. That's always a fun one. And then there's one, the 24 Deadly Sins of Software Security. I'm a big fan of that one. A security person from Microsoft, David LeBlanc, wrote that. And it's great. It talks about all of these sort of classic things that you're going to see. Your cross-site scripting, your buffer overruns, your unvalidated inputs, all of those sorts of things. And it does it in a very conversational way, a very practical way. I'm also going to plug all the GitHub security tools, because by and large you have them for free, and if you're not using them or something else, think about it. And then finally, I stole a lot of this from Microsoft. They bought GitHub, but I'm going to steal from them prodigiously. The security development lifecycle that they developed is really world class. So if you want to know more about some of the practices that are in here, there's a lot of long-form documentation you can read there to try and figure out how you can apply all of these concepts to your organization. The last thing I'll leave you with is your greatest asset, as much as your greatest risk, are your people. And it's not just the people you work with, it's also the people in this room. So I'd encourage you while you're here at GitHub Universe to make connections with other people that are like-minded. Because what you might find is the other people in the room have figured something out you haven't. And so I want to challenge you all to go and talk to 2 people you've never met today. And just ask them, hey, what are you doing for software security? What's working for you? And bring that back to your organization, because I bet you're going to learn some things. And we've all got things to teach each other. So with that, I'll thank you all, and have you enjoy the rest of your universe. Thank you, everybody.